Hi everyone, welcome to this 11th episode of the Future of Urban AI webinar series. It's a great pleasure of welcoming you today. Today we have the great pleasure to welcome Taras, CEO of Extra Dynamics. But just before starting the episode, a few words about the Future of Urban AI series and the methodology. I see some familiar names, so maybe some of you, most of you are already aware of this initiative, but for the new one, so the Future of Urban AI is actually drawing inspiration from the Future of Urban Tech Horizon Scan, which is a project that has been realized by Anthony Thompson, who is co-leading this initiative, the Future of Urban AI webinar series. And basically, in the Future of Urban Tech Horizon Scan, if you go on the website, you will be able to see different trends, different signals that have been analyzed based on online contents, but not only, actually papers, innovations, and several contents. And we used actually this map, this cartography to propose like a Future of Urban AI program. So the first season was last year, and we focused on the AI part of this graph, of this horizon scan. And like this, we had like 10 episodes during which we explore the future of urban AI with different speakers, different experts from actually all around the world. If you are interested in this first season, we published actually a report with forward from Michael Batty, a report that is freely available online and which synthesizes the main insights, the main learnings of this first edition. And following the success of this first edition, we decided to launch another season, which is the current season, for which we are adding 8 new episodes, 8 new exploration with global experts, global pioneers in the emerging field of urban artificial intelligence. And yeah, so we are having like a great program which is mapping more and more more and more trends. And today, for this 11th episode, we have the great pleasure of welcoming Taras, who is founder and CEO of Extra Dynamics, to discuss the use of AI in urban maintenance and to better maintain the built environment. As usual, we will first have a 20-minute presentation from our speakers, and then we'll have a 20-minute Q&A session. For this Q&A session, we will actually open the stage. So if you want to ask a question, you can directly open your camera and ask your question to Taras. But if you are shy, as usual, you can use the chat, and I will ask your question for you. Taras, the floor is all yours.
Okay, thank you. Thank you, Hubert. Can you see my screen?
Yes.
Great. So thank you, Hubert, for launching this webinar, and welcome everybody. I think that the topic, actually Hubert came up with, called self-repairing cities, is a very good one for us. We never thought about that before in terms of how we define what we do. But as part of our activity at H3 Dynamics, we're definitely have a vision of applying AI and digital technologies to help scale the maintenance of structures at scale, meaning self-repairing cities, okay, through automation and AI. So I'm going to take you through the vision of the company, what we're doing, where we are going, and then we'll open the floor to questions. So let's go to the next slide. So what is our vision for self-repairing cities? And I wanted to also kind of mention that when we say self-repairing, we're not talking about machines or HVAC equipment or, automatic staircases and elevators. We're talking about the actual structures, the building surfaces, the indoor structures, the outdoor structures, everything that's physical, I would say, in the scope of a city, and also beyond. It could be industrial sites outside cities, but we're looking really at the structures. And so IoT is kind of outside the scope of what we do. That could be attached to what we do later on, but we're I would say, really looking at the surfaces and the physical structures. So our vision is a kind of an infinite loop between diagnostics and repair, okay, where the city's alive, buildings have a life cycle, they are aging, and there's a continuous monitoring going on, with repair being an ongoing activity. So it's almost like the company started with diagnostics, but we're now really looking at how to digitize repair operations and have that as a continuous loop over the life cycle of a building and of a city. The other part of this in terms of context is the autonomous enterprise. So I don't know if you've all heard of this idea, but basically we're moving towards, inevitably with the development of AI, towards something that looks like stock market operations, okay, when we're looking at big corporations and complex operation management, right? So a room full of screens, which is very similar to a kind of a military command center, but at the scale of a city or of a company, whereby decisions are, being taken or at least being helped by AI, and there's very, very few people handling all these different decisions at the complex operational level. Okay, so that's the other part of this. It's the vision for autonomous enterprise, which is coming into play here. So a little bit about what we do and our company. So H3 Dynamics started in Singapore. Okay, I spent 12 years in Singapore, 20 years in Asia. So really spent my entrepreneurial career in Asia. We're expanding into the US and Europe, currently based in Paris. But we started our AI development in 2016 in Singapore together with the government. Okay, I'll explain that in a second. With a big focus on surface diagnostics and structures. We started a platform called H3 Zoom. That's the brand name of the cloud-based AI-enabled workflow automation platform. And our first solution on that platform entered the market in 2019. And I would say this year, our solutions, so the first solutions we've launched, have gone mainstream. And I could safely say that we're now a market leader in Southeast Asia when it comes to this whole approach. And it may be that we're also global innovation leaders when it comes to this space in particular. And we have the privilege of being associated to Singapore being one of the top smart nations in the world, smart cities in the world. And of course, when we're developing solutions in Singapore, there's also a global, let's say, lighthouse effect, I would say, for exemplary development in digital solutions. Now, I'm the founder of H3, but I also wanted to acknowledge during this webinar, Sean Koo, co-founder, and also the CEO of H3 Zoom, the cloud-based platform that I'm talking about right now. He's the kind of the one that put it together, and he's leading the team in Singapore. We have about 60 people working together with Sean, and kind of both on the R&D operations and delivery side. And he was recently recognized by the Singapore Ministry of National Development for the work that he's done in building facade inspection using unmanned systems, which was the first technical reference, world's first technical reference in this particular space. So let's talk a little bit about the service we offered. I'll do a little bit of an overview, and then I'll get into how this stuff works. So basically, the first service we've started with a while back was outer wall inspection. I'll get into the why of that, but basically what you see here is the result of an AI kind of scanning, thousands of very high definition images taken on very tall, big structures. This is a 254-meter tall structure, downtown Singapore. An example of the type of building that we're looking at, or that we typically look at. By the way, we've done something like 3,500 buildings already in Singapore of this kind of nature. And all these little dots that you see are defects identified by the system. automatically, quite precisely, and different colors showing different levels of severity. So here in red, there's 2 or 3 levels of severity defects at the top of the building. On the right-hand side, most of them are orange, meaning they require repair, but they're not a safety hazard. And in yellow means that they are aesthetic defects only, right? So it helps to prioritize the eye on, what is a critical problem. So facade inspection is the first product that we came up with. The second one is indoor unit inspection. So the same idea, except we're looking at placing defects onto floor plans automatically without human intervention. Okay, so that's another level of difficulty because there's no sort of GPS that helps you geolocate, defects on the indoor kind of spaces. So this is quite unique, and we've been leveraging our platform to achieve that. And so now we are also automating indoor unit inspections. And then we've also applied our platform to other areas such as workspace safety compliance, automating that, and the ability for institutions to check on company safety compliance for safety of workers. Okay, quite important in this space. Construction quality assessments. There are certain countries that implement guidelines on the quality of a delivered building. And so there's a check system that Singapore uses that we've digitized called Conquest, Construction Quality Assessment. And we've also applied this platform to port equipment. So there's plenty of use cases, but right now we've commercialized 5. There's a 6th one that's coming out, which has to do with the building energy loss identification, which is linked to the building CO2 impact. And you know that buildings are responsible for as much CO2 emissions as the entire mobility sector globally. So anything that we do on CO2 reduction with buildings is going to be good for the environment. So we have a way to now also track, thermal bridge and energy loss measurement from the surface of buildings. This is coming out shortly. So why are we in Singapore? I mean, Singapore, beyond the fact that we're a leading smart nation, we're at the center of, a big urbanized cluster globally. Okay, the circle I drew here is basically majority of the human population is living within that perimeter. Okay, and it's living in cities, mega cities. You can see the size of these cities, and so obviously, the impact of our development is focused on this part of the world right now, where we will be looking at bringing it to other parts of the world, but we're really focused on mega cities, right? When I say mega cities, this is what I mean. And some of you know Asia. I'm sure you all know Asia, but this is not something we could compare with, for example, Uber in Toulouse. Probably you don't have this situation, right? So this is very, very relevant to the Asia region. This is Tokyo. Okay, so it's really like urban jungle, bunch of cement, millions of people living in concentrated environments. And what this tells you right away is the scale of massive structures, right? And now the limited ability for people to manage the life cycle and the aging of all the stuff that we've built, right? In Singapore, I'll get into that in a second, but in Singapore, we have a very stringent, or let's say a very difficult labor shortage situation. But it's the same in Tokyo, and it's the same in many other places now. And when it comes to checking on the state of buildings, well, not many people want to climb on a rope to do that job. Okay, we've all kind of evolved in terms of what we like to do in our day in life. So besides that, cities are aging, including Singapore. This is a sort of a case that is representative of situation and the reason for a new law that came into play in 2022. Okay, but it was in preparation for a while. But basically, because of the aging infrastructure, and we know that there's cases like that everywhere around the world. There was cases in Florida, cases in New York, where parts of the buildings are falling to the ground, right? Falling to the ground and sometimes can be fatal. In the case of Singapore, luckily, we didn't have any accidents yet, but it can happen, and that's why there's an urgency now to go and have a very regular check on the state of the building. So you see on the right some news articles about the law that passed. In the case of Singapore, I think 90 pieces of buildings fell in the last 3 years, okay, from these tall skyscrapers. So it's a problem, right? And the problem is that there's 40,000 buildings in Singapore. Okay, so the question is, how do you solve this problem? And well, one of the answers is obviously AI. And the other one is robotics. Okay, robots, because not enough humans to go and fix this problem at scale, right? So the way that we entered this space actually was with the government. So there's a JTC, which is kind of a government agency in Singapore under the Singapore Ministry of Trade, okay, that manages all the different industrial hubs in Singapore. It manages the heavy industry hub, Jurong Island, but also, the biotech hub, the IT hub, so on and so forth. And it has many thousands of buildings under management. And it's also in charge of, by the government, to kind of invest in R&D for, let's say, all this kind of smart nation engineering capability for the future of building and infrastructure technology. So we started with them and kind of got into the space and understood the way that things were going on before we got involved. So this is probably the case for many cities around the world still, okay? But in Singapore, this is kind of what we were confronted with in the beginning. So we have on the left, someone on the rope taking pictures, okay, of the surface of a building, of a tall building. And on the right, it's basically a report submitted by an engineer, signed and stamped. You can see the signature and the stamp somewhere in the top part of this image, okay? And all these manual annotation on a very modern building, okay? And this is Singapore. So, talk about the need for digitization here. And this file would be somewhere in a cabinet on top of that, and not really easily accessible. So this is before, and this is kind of after. So we've removed the need to put humans on a rope, okay, by automating scans using modern technology. So a camera, okay, just a HD camera, thermal camera, with a drone that can kind of follow a very precise scanning trajectory around the structure, okay, as a scanning activity. And there's nothing special about that. I would say, some technology, but, frankly, that's really a commodity now, and everybody can do that. And the outcome through our system is basically a completely digital and interactive solution that covers, tall structures, much more than just condition assessment. And you'll see we're going very deep in how we're helping to help cities to self-repair. So we removed work at heights. We got incredibly faster, so 90% faster completion. Okay, that's what we want for scale. It's also cheaper to operate, huge productivity gains, and it's also more accurate because we're using, high definition cameras, thermal imaging, and very good positioning capability. And so as a solution, it's kind of end to end. Okay, there is still human in the loop, but what we have is a single pane workflow where we've kind of congregated the different elements of the ecosystem, the professional engineers, the inspectors, the architects, the end users. We've linked it up to through APIs to ERP systems, to BIM enablement with Autodesk, and so on and so forth. This thing is available through SAP as well, because now SAP is offering that up to its customer base, as well as some parts of Oracle. Okay, we didn't eliminate the human involvement because we need human experts, to be able to sign off and validate what the AI does. Okay, the AI cannot, by law right now, just do everything on its own. Right? We can do it technically, but we still have to have someone to check and make sure and put his name on it, like a doctor, right? Like a doctor looking at radiography, right? Now, the difference is that this doctor or this expert can now do 10, 20 times more work than he used to in terms of looking at various, outcomes. In the past, it would take him a lot longer because he was looking at photos and trying to place the photos on specific parts of a building. Now, he's just looking at what the AI has come up with, even the recommendations that are coming out from the AI side as well, because we automate the recommendations, okay? And he's just checking that those recommendations for repair are correct. And the more he checks that, obviously, the more our AI gets smarter, right? Because that's also in the loop. So since then, since the last, I would say 2-3 years, actually, since we first met with Uber, the solution's gone mainstream. So now we are entering multi-year contracts with the leaders in the space. So facilities management companies like Cushman & Wakefield, big real estate investors like CBRE. We just entered a 9-year agreement with CBRE, which is kind of historical, to give you an idea of how this is already kind of going mainstream now. Okay. We've also entered an agreement with SoftBank Robotics. They're taking the solution into the market in Japan right now. Okay, they're applying it to the Japanese situation. We're also working with Bouygues, and all three of us won an award together recently for the facilities management technology innovation. Okay, so that gives you an idea of our partnerships and how we're bringing this together. So we're not at a stage where we're working on closing the automation loop, right? I mentioned about diagnostics and looking at repair, and how can we now close the loop on this activity? Because you can still see that there's some inefficiencies or some friction because there's some human involvement in acquiring the data, especially, right? Our vision is really, when you look at the autonomous principles for autonomy, right? You have these 4 different phases: ability to observe, ability to infer, ability to decide, ability to act, right? So our vision is for all of that to be fully autonomous in the scope of what we do for cities, okay, and buildings, okay? But where we are right now in our system, okay, is, I would say, mostly semi-autonomous, okay? We help human beings and experts go faster using AI, just similarly to ChatGPT, I would say, and what we may do with contract development. For example, instead of calling my lawyer now, to draft a contract, I can do 90% of it myself using ChatGPT, and then give this result to a lawyer so that he only spends the 10% of his time to do the checking and adjustments, fine-tuning, right? So that's why I call semi-autonomous here. A lot of the activity is semi-autonomous. We're able to go fully autonomous on maybe 1 or 2 areas, okay? But the one area that we're looking to push hard on is the fully autonomous ability to observe part, which is eyes and ears, basically. Ability to act, I would say, is also an area that is manual today, but you will see that there are movements towards fully autonomous repair. So ability to act is, okay, first of all, deciding what to repair and then going out to repair. So that work is still carried out by human beings on a gondola, okay, but that is also moving to automation, and I'll show you in a second. So the first thing is automation in observation. So this is Singapore, okay, a map of Singapore, where we were 3 years ago and where we are right now in terms of numbers of drone flights to inspect buildings, and that's just because of H3 Dynamics platform, okay. And these are real numbers, and you can see that these numbers are numbers of drone flights per district, okay? And so we're kind of like, we're seeing a huge increase here, 440 drones, so maybe more than 10 times growth in the number of drone flights in a very short period of time. What that's telling me is that we're running out of pilots, okay? Now we've done way more than what a person on a gondola can do, but now, what happens when we need to scale beyond drone pilots, right? So that's a new thing. So we've anticipated that 7 years ago. While we were developing the AI system, we started the development 7 years ago, and this is the latest iteration. We've done 7 iterations of this robotic system. Okay, it's a little bit ahead of its time, to be frank, because this is slightly science fiction. We're talking about no human intervention, a system that comes out of a shelter, so a drone that comes out of a shelter on a building rooftop, goes out to take care of one building, scan, comes back, sends the data, and a report comes out, and it sends a job for repair. All that without any kind of human intervention. That's kind of the direction, but ahead of its time. So this is already something we've been testing in Singapore for some time. And you can see, I was mentioning to Hubert earlier, that this activity is, in my opinion, the beginning of urban air mobility, in the sense that urban air mobility is kind of similar. You're talking about drones that ferry passengers from one place to another, okay? And there's a bunch of air taxi companies out there that are looking to do that. One of them just got the approvals, by the way, in China for, autonomous passenger flight. Imagine that. So the state approval has happened for a company called EHang. And so what you see here is a 4-ton passenger drone on the right, and on the left is a tiny little drone which weighs about 9 kilograms. So it's a lot lighter, it's a lot safer in case of a problem. But it has a job today, which is to kind of scan buildings for defects. So we think that the evolutionary start is on the left, and as more of this happens, you will see things evolve towards what you see on the right. Okay, bigger and bigger things. And so on the right here, you see kind of an autonomous landing operation. So there's no pilot here in the little video. The drone finds its way back, and the shelter kind of protects it from the environment. And then the data gets kind of sent to our platform on the cloud. And then basically you get a result. There's been so far no human intervention. Of course, at this point, there would be a check by a professional engineer. Okay, we don't know where the law is going to go in terms of how professional engineers and versus AI, and what is going to be more precise, more accurate in the future. But right now, the law says professional engineers are signing off. Okay, so at this point. And then the final stage here is something that's already going on, at least in terms of testing, is automated gondolas. So these are autonomous gondolas that go out and paint and repair cement cracks, and they go and do that based on the location that has been pointed out by the AI that's on the cloud, right? So all these things are communicating amongst themselves. And we can imagine that this is kind of the future of what we call self-repairing cities, right? In terms of the whole process, where humans kind of become spectators. The managers, the facilities management people become a spectator in terms of all of this ballet, right, activity between diagnostics and repair and continuous monitoring over the life cycle of these buildings, right, of the entire districts and cities, moving into this autonomous enterprise kind of vision. So I'll stop here in the presentation. Hopefully that gives you a broad idea on what we are doing. I didn't go into too many specifics on the technology stack. Okay, some of the stuff is a bit confidential, but hopefully this gives you an idea of the direction that we're taking, and the kind of progress we've made in the last couple of years. Sorry for the date here. I put 2022, I realized, but it's 2023.
It's okay. Thank you. Thank you very much, really, Taras, for this fascinating presentation. I think it was really an amazing vision that you just shared. Anthony said it in the chat, and I would say that I quite agree with him. It's quite mind-blowing, actually, what you are proposing, both in terms of technology implementations and vision. Well, personally, I have a lot of questions, of course, but if you have any questions you want to ask, please feel free to like we will open the stage actually. So feel free to just open your camera and then directly ask your question to Taras. And if you cannot, you can use the chat as it's already the case. Taras, maybe I have at least one question which is very operational, but in terms of business model, like how does it work? If I'm a client, am I going to buy a drone or is it a platform? What is it? Yeah.
So right now, so you have to imagine that what we are installing is progressive. Okay, it's step by step. The first step is a digital platform, okay, which is data in and result out, right? And the data in is kind of like very similar to how you upload data on Google Drive, something like that, right? So while you upload on Google Drive, our systems are analyzing and you're getting your results right away. What the customers are buying right now is access to the platform through a subscription model. And the more buildings they are analyzing, you know, the more the subscription kind of increases in size, right? That's step one. They are free to use their own drones. Sometimes our customers have their own drone operators. Okay, we see that more and more. Sometimes they will use drone service fleets, companies that actually provide services for manual drone flights. There's thousands of companies like that all over the world. I would say that's more like a commodity activity now. Okay, but you do need your expert drone operators that are certified, able to fly drones in a city environment. That's actually okay for professional drone operators. And then we may provide some of those services as well, in some cases, to help train our customers. But it's I would say a separate activity to the cloud platform. So why we are separating it is because we can easily transition from manual data acquisition to autonomous data acquisition, and we're also I'd say agnostic to the method. It's not just drones, right? In some cases you cannot use drones, right? Some cases, you know, the spaces between buildings is too tight. Let's take Japan, for example. So concentrated that, you know, buildings are so close to each other, and sometimes you have these electrical wires that are, you know, above ground, right? So you don't want to be hurting, you know, all of that intricate kind of infrastructure. So one of our clients came up with a drone on a rope idea, where they drop a camera on a rope from the building rooftop, okay? And this has a similar geolocation positioning capability as a drone. And so the images taken by this camera on a rope is equivalent to what a drone can do, right? Another way that data can be acquired, this is happening in indoor inspections, and that's what we're doing with SoftBank right now, is cleaning robots. You know, they're out there all day, basically cleaning the floors, right? So it doesn't cost anything to have a camera on there that, you know, just continuously captures images. And at the end of the day, sends them all to our cloud, and all these images are then analyzed. And next day in the morning, there's a report that says, go fix this window because you've got a crack, right? And so that's another method. So we are really sensor or camera or method agnostic. It just so happens that we started with drones in the beginning because big, tall buildings, you know, there's not that many ways that you can use cameras outside, and drones are obviously the right way to do it.
Super interesting. Super interesting that you see that you are not like hardware dependent. You are providing something much broader actually.
Yeah.
So we have actually many questions. We will ask with maybe you. I hope I will pronounce your name, Shmuel. So if you want to open your micro and ask your question.
Thank you. I want first a very interesting presentation, and I want to ask you how experience of AI in Singapore can support improvement management of cities and municipality services and infrastructures in the times of emergency and different disasters.
Yes, you're absolutely right. I was actually at a disaster management conference not too long ago, and I spoke there in Singapore. Obviously, disaster management is one of the applications. So I think it was Anthony that mentioned on the chat. I noticed that there's so many applications. It's true. I didn't put the slide up, but once this infrastructure is set up, this autonomous infrastructure is set up in a city, it can be reused for other things, right? Not just inspection of building structures for maintenance, but the same infrastructure can be used to respond to disasters, to respond to traffic incident, to respond to a national security challenge, right? The systems they can respond quickly. Okay, they're like a mini helicopter, you can say, but a much cheaper one. They can provide live footage if necessary. AI can then be placed on the footage as well to provide special information. We then can use the same infrastructure for delivery, okay, from point to point and multiple delivery points, right? We can use this for insurance purposes, okay? Insurance companies can use this as well if they wanted to check on a structure prior to insuring it, okay? That's something that we also noticed. So there are many possibilities for this and disaster management, not just in the city, but in other locations, such as industrial sites, borders, affected structures after, let's say, an earthquake, to be able to check on structures and quickly identify emergency areas or safety problems is something that the system can be applied to as well.
Thanks, Taras. Ruth Nelson, you have a question. If you want to open your micro, maybe just before, also feel free to introduce yourself if you want.
Hi, hello there. My name's Ruth Nelson. Thank you so much, firstly, for your presentation. It was really fascinating. So, from my understanding, you're aiming to sort of automate all of these processes. And I'm wondering if you've sort of identified any risks in relation to this automation and kind of taking the human out of the loop, or you feel that the benefits and the gains from efficiency outweigh any potential risks?
I would say for the time being, we are not removing the experts from the loop, right? The experts are like the doctors, right? You would not remove the doctors from the loop either when you're looking at a scan of let's say for cancer or for lung treatment or something like this. You still need a doctor to take a look at that and advise, right? And it's the same for these structures, and they by law and by maybe legal obligation need to sign off and stamp, right? So this, I can't see it going away for the time being. It may happen that it will, okay, because who knows, maybe this system will get more accurate and make better decisions than even the best expert. Don't know yet, I can't say it, but this is, in the current time, it's like we must have the human experts in the loop for liability reasons. And then I would say what we have done is we've removed humans from the loop where humans were at risk, right? And so, there are people falling from heights all the time, okay, unfortunately. And the jobs we're talking about here are all the time about people being put at that kind of level of risk. So whether they're in a gondola, whether they are on a rope and descending a building, we're talking about very tall buildings, and this is happening on the scale of entire cities. We want to minimize that risk. So 0% work at height risk is something that we are proposing as a benefit. Meanwhile, the experts, we don't remove them for the time being.
Okay, thank you so much for the clarification.
Thanks, Ruth, for the question. Taras, you were talking actually about regulation, and we have a question from Luis San Vicente, who is asking basically like, who is your clients in Singapore, and more precisely, why are they collaborating with you? Is it because they are worried about their infrastructures, or is it because of a government obligation that, like, the government would oblige building to assess their facilities?
It's a bit of both, actually. So people are checking on the state of the buildings because, first of all, they're liable for the safety of their buildings, right? So they need to check them. They also have customers. So if it's commercial real estate or residential, people are paying for a certain standard, and they need to make sure that the standard is upheld. And therefore, they want to keep the standard up. And that Singapore is a pretty good standard there when it comes to building quality. And there's competition also in terms of who will deliver the best quality, et cetera, et cetera. So I think on the one side, there's a private interest in making sure that things are done properly, and digitization helps to allocate resources to the right building at the right time, rather than doing these kind of random checks, which is what the case was in the past, where you don't know what you will find at the time that you're doing the check. Whereas here we can do a quick scan and send people where the most urgent activity is needed. So this resource allocation is a good idea. And then government, in Singapore, we have both government and private customers, right? So government buildings, social housing is under the government in Singapore. It's about 11,500 buildings. Okay, so buildings that are typically 25 stories and above. So that's really a lot of buildings under one government agency called HDB. So in Singapore, there are 17 town councils. And our system is being used in 15 out of the 17 town councils right now on those kind of HDB buildings through 2 or 3 companies, which already have the maintenance contracts with this government agency, the social housing. So it's not being done directly. It's done with the existing inspection and facilities management companies that are, in fact, transitioning from, let's say, manual paper-based operations to automatic and digital-based operations. Yeah.
And actually, as you were, that's also interesting, because I was just thinking about it when you just answered, and because of Ruth, who is actually doing her PhD on urban inequality. But your solution basically making able to better access, like in a more equal way, urban maintenance, because you better allocate those resources with your drones, maybe.
Yeah, well, let's say that imagine the condition of every building in a city, right? In detail, every single defect on every single building across the entire city. So then you start to be able to, the system will be able to rank the worst building to the best building, right? We already do that, and some of our customers have hundreds of buildings under management, if not thousands. And so to be able to know which is the worst building and which is the best, and then rank what is in between, already helps you to save money on those random inspections that you are operating. Okay. We also have another process in inspection, which is the non-destructive testing. So the physical inspection. It's not just visual. Okay, it's actually going to check where, check doing some random checks on the surface with knocking and sensors and stuff like that. Typically, an expert does that job as well. So we've also digitized that process. Okay, drones are not doing that. Humans are doing it, but we've added their checks into our platform so that the end user has the entire picture there, physical and visual inspection. But we're helping to direct the physical inspection. We're helping to direct this physical inspection based on the initial scans that we would have done on the surface, right? So if we see that, hey, you should go and check this area because it doesn't look right, typically those NDT professionals wouldn't know that when they conduct their random scans.
Afid, you have a question that you want to ask, maybe?
Yes, Hello, thank you very much first for the presentation. It was super interesting. Yeah, I had some questions, but I think you've answered part of them. The first one was around the physical check, but I think that what you just mentioned, because I've seen some kinds of project like this where the first scans were useful, but to then plan the repair works, they still had to go physically. So that's still in fact done. They still have to physically go on sites to check the problems that scans have revealed.
That's right. It has been an issue for us in the beginning. So when we started this whole process, we could only do visual inspections, and so it was only partially responding to the customer requirement or to the city requirement. And so the question is, how do you fix the NDT part? Like I said, the NDT is kind of guided now, number one, by our system, and number two, we are actually subcontracting the NDT in some cases, okay? Because our customer are requesting the entire solution from us, from our platform. And as we subcontract the NDT activity, we've provided the inspectors with a way to upload their results onto our platform so that they then integrate to the complete picture that we provide to the end user, not just visual, but also physical. If that makes sense. Hopefully it makes sense.
It does. Maybe I have just one other question and one comment. The other question was on the prioritizing of intervention. You mentioned like the colors for severity. I'm wondering if that was something that was integrated to your solution or something discussed with each client to know how they want to prioritize the interventions according to their means, or if it was integrated into your solution.
Yeah. So there are standards in terms of what constitutes severe, or let's say unsafe, safe but needs repair, and aesthetic. Okay. So these are the three kind of color codes that we use. Okay. And then the AI is able to basically, attribute each defect it finds. And we have 34 different type of defects we can find on 4 different structures or surface types, including glass and steel and concrete and, others. So they're kind of quite broad. We are also now able to estimate the cost of repair. So the AI is able to provide a $sign on every single one of the defects to say, okay, this one, we estimate the cost of repair to be about this many dollars, which also then helps to provide other people or other users, the ones holding budget for repair, to also prioritize a budget based on what is, the most urgent to the least urgent. Okay, we have some ideas about where that can go in the future, because I think that's kind of interesting. If you know the cost of repair for every single defect across an entire city, that's you're opening a whole new box here. so this is sort of where we're going, I think.
And to finish, and then I won't say a word anymore. It's more of a thinking that came up because I was seeing your map with all the flights, and I was thinking about how your work could also provide maybe insights to the construction practices. If you can, for example, say that maybe in some sectors that have been built in a certain way, you can see that there are some kind of defaults that appear a lot, maybe that can also, I don't know if that's something you plan or you're doing or is in the scope of providing insights to some construction here, bad practices that may have happened at the time where those buildings were constructed. So maybe it could be interesting also through the data you're producing.
Absolutely. And there's certain places in the world where corruption exists on the inspection versus regulations and authorizations. And what we could imagine in the future is some kind of a digital lock or kind of a blockchain approach to certifying this information and making sure it cannot be changed or modified by anyone, so that we have a very level playing field for the facts, okay, with regards to a newly constructed building and how this building evolves over time. That's kind of important. The other thing that we found is that over the life cycle of the building, the more there's a track record of maintenance, which is digitized and goes in over time. You can see all the work that's been done over a period of time, the better for the building owner in terms of his or her ability to justify the value of a building, right? So in the past, all this work was difficult to kind of present, but we have a way to do that now with the kind of accumulated data we're getting on the repair diagnostics loop that I mentioned. So yeah, I think this application of corrupt practices plus making sure that people don't cut corners on construction, that's an area of application for our system. But we don't have this problem in Singapore. We probably will face this in certain other countries.
Maybe a final. Oh, sorry.
Just saying thank you.
Thanks, David, for a question, and maybe a final question actually from Anthony Tenson, who was asking in the chat basically who would like to hear more about the CO2 energy performance monitoring you mentioned during your presentation, Taras.
Yeah. So first of all, we think that applying our technology to cities just for the activity of maintenance is already kind of a green solution, because these drones are electric. We're not using diesel generators to push gondolas up all day long all over town, which is the current method. Okay, I see the diesel generators on those sites, and they are noisy and they're dirty, and that's already a CO2 removal. Okay, the second part of this is now that we are starting to understand how these buildings are performing, not just from the equipment standpoint. That's not what we're doing. We're not looking at the efficiency of an air conditioning unit or HVAC system or things like this. We're not looking at that. We are going to look at the building surface issues, right, with maybe water leaks and cracks and maybe areas that are open to energy loss, right, heat loss or cooling loss. In Singapore, it's a huge amount of air conditioning being used. There's a whole part of the world which is really using a lot of air conditioning, okay? And there's a massive CO2 emissions connection to this intense use of air conditioning. In some other countries, it's going to be about heating. But yeah, we're very excited about this new capability we're coming out with. It's taking us a while to develop it, but we're working closely with some important partners that are keen to launch it, because we all know that sustainable buildings is a big topic, and we think we're onto an application that has been missed by those that want to look at sustainability. It's not just about the equipment that's running, the heating and cooling of buildings. It's the building themselves, and that's we're excited about what we're finding here.
Thanks a lot, Taras. Maybe one last question, very, very quick, because when I see all you accomplished in just 3 years, I cannot not ask you where will you be in 5 years or 10 years? Like, what is your long vision for H3 Dynamics?
Well, I only talk about today one part of H3 Dynamics, right? And it's I would say the heart of what we're doing on AI and robotics, with a big start in Singapore. This is expanding into the Southeast Asia region. We have activities now in Vietnam, in Thailand, in the Philippines, in Australia. This is also now expanding to Japan. It's going to go into the UAE space. I mean, it will go global, okay, little by little, but with Asia being a big focus, as I mentioned earlier, it will also start to translate to other industry applications. So smart cities is a starting point. I think after that, we can look at water infrastructure. We can look at energy infrastructure. We already kind of installed a system in Austria on a power plant, okay? So we can imagine that such as technology could be running on industrial sites, not just in cities. And what we're imagining is a platform of digital solutions, okay, which we may or may not create all of them, right? You know, when Apple, you know, designed the App Store, Apple didn't create all the apps, right? So they have an ecosystem of applications which could involve many different developers out there, which could join our system so that we can redeploy it globally, okay, through this robotics approach, right? So that's one direction in terms of the future. In 5 years from now, I think most likely we'll become big on the city front, and we would have expanded into other industrial sectors, but running with the same technology. I think we're on the edge of regulations, and some of the stuff we do is a little bit science fiction. You're talking about fully autonomous operations, out of line of sight, out of human control, okay. And I think in remote locations that might be okay. In cities, it's still not yet there. But when you consider that a company just got approved for autonomous passenger flight in a drone, right, two-seater passenger flight. So although we're at the edge, I can feel things are moving in this direction. And so, yeah, I'd rather not say exactly how things will pan out, but I could imagine that things that will surprise us are still ahead.
Thank you. Thank you very much, Taras, for sharing your vision for this presentation. We asked actually at the end of the presentation to the audience, what is the most prominent benefit of self-repairing city? And so just to let you know the answer, 46% believe that it will reduce infrastructure maintenance costs, sorry. For 21%, it is about improving public safety. For 13%, it is about increasing sustainability. And for 21%, it is about improving disaster resilience. Thanks again, Taras, really for your presentation. Thanks to all of you for your questions, for your participation. That's already the end of this episode that will be very soon available. The recording will be very soon available on our YouTube channel. And next week, we will host another Future of Urban AI episode with Anthony Tencent. Bye and have a great week.
Thank you all. Bye-bye.